Good evening, everybody. Have you had a fun day? Excellent. That's good to hear. So, continuing on the craft theme, I'm going to talk about some art, and specifically the art of visualizing software architecture. And this talk has really been inspired by a couple of simple quotes. The architecture diagrams never match the code. Does this happen to you? Excellent. Well, not excellent, but we can fix that. And secondly, how do we draw diagrams? Does anybody have any tooling suggestions that are not Visio? I get this a lot. So these are the two types of questions that we're going to answer this evening. I live in Jersey in the Channel Islands. Can you see Jersey on this map? No, because it's too small. If these were big interactive touchscreens, we could pinch to zoom in, and magically Jersey gets a bit bigger, still a tiny bit small. Pinch to zoom in one more time, there we go, there's Jersey. 15 kilometers by 800,000 people, island in the English Channel. Why on earth do I live there? Because it's nice. The weather is exactly the same as here. These photos were taken on the 3 days of the British summer, but whatever. It also took me 12 hours to get here on Tuesday, door to door, 12 hours, 200 miles away. Go figure. Over the past few years, I've been jetting around the world and helping teams understand what software architecture is all about. And a lot of that is around how we balance architecture and agility. It's about technical leadership, and it's about drawing pictures and visualization. And really my picture is that architecture needs to be much more accessible to us as software developers. Sure, there are lots and lots of books out there, but when I was moving into my first architecture role, I didn't really understand how the stuff in those books related to what I should do as a day-to-day architect. So in my naive approach to solve this problem, I just wrote some different books. Seems to be working out so far. The one on the right, the Art of Visualizing Software Architecture, you can go to LeanPub, find the book, slide the price slider to $0, and buy it for free, if that makes sense. So all the stuff we're going to talk about this evening is in the book. I do write code as well. Yay. I think this is important because for me, software architecture and coding development are just two sides of the same thing, and we need to reintegrate and join them back together again. Right, so let's talk about the problem here. One of the things I do, and this is why I came to Endcraft a couple of days early, I ran my workshop. And basically what I do is I say, here's a simple set of requirements for a financial risk system. Go away, create groups of 2, 3, 4, 5 people, come up with a solution, so do some design, do some architecture, and then draw some pictures to somehow describe your solution to other people. The requirements are very, very simply, we have 2 source data systems. We pull the data in from each of the systems. We perform some calculations, and we basically generate an Excel report. So that's it. Also, there's the ability for some special admin users to modify some configuration parameters. Now, thankfully, we don't do class-level design anymore. So I didn't see people getting out UML tools and doing really, really low-level details, UML class diagrams. And indeed, if you gave me one of your code bases to visualize, I wouldn't draw you a class diagram that included every single class in your system, because it's just too much detail. So we use abstraction. And abstraction is a way to essentially reduce the cognitive load, reduce the detail. So rather than drawing lots of small classes, we draw bigger things. Modules, components, services, subsystems, layers, and so on. Here are some pictures from some workshops. These are real pictures. I promise I did not make any of them up. So this is one of a collection of diagrams a group produced, and it's basically just a shopping list of technologies. Unix, Windows, JBoss, SQL Server, and we're done. This diagram does not tell you anything about the solution, the responsibilities, and oddly, there's no link between the stuff on the left and the stuff on the right. This is what I refer to as boxes and no lines. Can you guess why? Because it has boxes and no lines. This looks like a 3-layer, 3-tier Microsoft solution. ASP.NET box at the top doing something, I hope. There are no users, which is a bit disconcerting. Bunch of database things. Well, I guess they're databases. Cylinders. Could be schemas, tables, who knows. And some stuff in the middle. Modules, components, services, not really quite sure. This is what people often refer to as a functional view. And it's basically just a list of stuff. Imagine you're having a house built, and you ask your building architect to draw you a functional view of your new house. Eating, sleeping, dining, entertaining. Right? It's not particularly useful. Plus, we have some weird color coding here to decipher. I like people on pictures because people provide some sort of context as to who's using my system and why. But please give them a name. Otherwise, they're just faceless clones. They're stormtroopers attacking your system, and that's probably bad. So we need to give people a name. Oh, I love this one. Next time you go flying in an airplane, open up the magazine, you'll see this architecture diagram. So the stuff in the middle kind of represents the major steps in the process. We import some data, we perform some calculations, we generate a report, and then we distribute the report. That kind of makes sense. And then all hell breaks loose. Right, this box here, this circle here, the green one, is important because everything is pointing towards it for some unknown reason. There's also a clock pointing to the important thing. On the other side, we have different line styles, colors, shapes, and all sorts of things going on. That says user interface, UI, upside down. Can anybody tell me why? Yeah, because people were sitting on the other side of the table. That's it. It's just laziness. This diagram describes all of your software systems today. The big red box is your system boundary. Inside your system, you transport data in and out, you audit events, you generate some reports, you deal with errors, hopefully. You have some scheduled jobs, and you do business logic. Yay. This diagram is totally useless. It doesn't even tell you it's a financial risk calculator thing. This is what some people refer to as a logical view, and they call it a logical view because it doesn't include any tech choices. I ran my workshop a couple of weeks ago in Europe, and we had a 2-hour conversation on this slide alone. Including technologies on diagrams is apparently a very, very controversial topic, and we'll get into that later, of course. You've heard of POJOs, plain old Java objects, and POCOs, plain old C# objects. This is the homeless edition, the HOCO. At the bottom, SQL Server database. At the top, a box labeled application. It's a console C# application, judging by the green text. What's everything else? Well, we've got a data loader thing, and a calculation manager thing, and a risk calculation thing, and most of these are annotated to C#. So I'm guessing they're C# objects or components or modules or something like this. And it's just a really weird diagram. You know, we have this big database and all of these little C# things kind of floating around. And really what I want to do with this diagram, I think this is just a C# application talking to a database. So really, what I really want to do is draw a big box around all of these C# things to essentially give them a home. There is a top and a bottom. I've skipped it to save your eyes. When I was a kid, we had these storybooks. They were choose-your-own-adventure books, fighting fantasy books, I think they were called. And you start from page 1, and you read through 10 or 20 pages. And then you get to a fork in the story. And depending on which page you turn to next, you change the story. I used to love these books as a kid. This diagram is basically the same sort of thing. You start at the top and you go down through the picture. And you get to follow different paths through the architecture if you want to. Fail events, complete events, reject events. When I was a kid reading these books, my character always died. Now, maybe I was just unlucky, but it was really annoying because you have to start from the start. This diagram is exactly the same. All paths eventually lead you to the trap. It's all one color. This is showing a much more kind of complex, asynchronous, event-driven style of architecture. There are very few technology choices. There's a stormtrooper. The thing I love best about this diagram is the calculation engine box. A plus B equals C. Yay, microservices, adding 2 numbers. This is why whiteboards are useful. Report repository, we don't need that anymore. We don't need this line here. Oh, yes, we'll do. We'll put it back. And they say that naming is hard. So, yeah, we rename some stuff. And if you take this to its logical extreme, you get that. Again, this is like a real diagram a group produced and delivered. And it started out life as an entity relationship diagram, as a crow's foot symbol. And the box in the middle, I think, was important because it was placed in the middle, and everything links towards it. And then they scrubbed out the middle box, and the diagram is basically useless. I've got another 15 gigabytes of photos. Do you want to see them? We'll stop there. Sometimes when I'm doing this workshop, I kind of listen into what people are saying in their groups, and they'll often say things like this, right? The diagram doesn't make sense, but we'll explain it later. Right. Do you see what you've done there? You've basically produced something no one else can understand. And everywhere that diagram goes, you have to go with it. That's an awesome way to keep your job, but it's not a very good way to draw a diagram. To kind of further emphasize this, what we do is, as I said, we break people up into groups, and they're quite happily working away for about an hour and a half on their solution, drawing their pictures. And the assumption here, of course, is that they're going to stand up at the front of the room and present their diagrams. That would be too easy. I don't do that. What I do instead is I get them to swap diagrams. This is a little bit of a nasty trick, because guess what happens? As a group, you now have a set of diagrams you don't understand, because you weren't part of that 90-minute conversation about the different boxes and the shapes and the colors and all that sort of stuff. And basically, when groups see a different set of diagrams, I don't do cat pictures in my presentations, but what? And there's so much stuff that gets misunderstood or is ambiguous. And basically, the diagrams make no sense. And they say things like this. We actually asked them, to put some structure into this, we asked them to review the diagrams a bit more formally. And they say things like, well, I'm not sure what this shape is. You know, what's the DB like, the cylinder icon? Oh, you've lost a sticky note here. It's fallen off on the floor. Let me get it for you. Why are you mixing these different levels of detail? And so on and so on and so on. And then we say to people, well, what did you find hard about this exercise? And they go, well, we've never done it before. We don't really know what's expected. We forgot to ask who the audience was for these diagrams. We don't really know how much detail we should draw. In fact, we don't know how much detail we should design down to, right? Two different things. We're not sure about notation, and so on and so forth. And I've run this exercise all around the world, and we get the same sorts of things coming up again and again and again. Right. Let's risk something here. Show of hands, who uses UML on a regular basis as a part of their job? 0, 2, 3. What's everybody else doing? Writing code? Not doing diagrams, boxes and lines? I've asked this question everywhere I've been, and I need to change this slide because I think this is massively optimistic. Because I'm now seeing many, many more audiences where nobody uses UML. I think even if we look back to UML's heydays of sort of 10 or 15 years ago, I think maybe only 20% optimistically of people were using UML. And it's definitely something that's on the decline for a number of reasons. Ooh. So I do use UML a little bit, and I use UML when I want some low-level precision. So UML is great for capturing tiny, tiny parts of a software system at the class level. Sequence diagrams and collaboration diagrams, communication diagrams are useful for showing runtime interactions of things. State charts are great if you're modeling a state machine. Activity diagrams are great if you're modeling workflows. And that's pretty much it. UML 2.45 has 20 different diagram types. I use 5. I have no idea what the rest are. They don't enter my life. I don't need them. If you're going to ask Google what it thinks a software architecture diagram looks like, it basically gives you stuff like this. There are some UML pictures in here, but if you don't want to use UML, you'll just ignore that stuff. And ultimately, what you get is a bunch of very pretty, colorful block diagrams. And these are basically the types of things I see when I go and visit organizations around the world. You know, show me your documentation, show me your wiki pages. Ah, we got stuff like this. Do these look familiar? This is what I see particularly large enterprises, because people love PowerPoint, they love Visio. if we take this diagram I've highlighted here, we often talk about layering being a good thing. I'm not getting into that discussion here. I did that at DevOps Front. So we have a diagram showing layers. The layers are different colors for some reason. At least they have a nice gradient shading. Looks nice on a PowerPoint slide, I guess. Some stuff doesn't fit neatly into these layers, so we have these vertical layers that stop the diagram falling over when they're drunk. Acronyms on here. No lines, no structure. Different boxes, different heights, different widths. Why? No idea. And so on and so forth. And the pattern's repeated over and over and over again. And I will hold my hand up. I used to draw diagrams like this. And then I saw the light. This stuff is hard. I think maybe 10,000 people have done this workshop in various countries around the world. And everybody struggles. It's just not something that we do anymore. It's not something that we teach people. It's not something that we talk about. And the real irony here is agile. One of the fantastic side effects of the whole agile movement is transparency and visualization. If you go to any office of any organization, of any team who are following agile approaches, they'll have their Kanban boards and their story walls and their information radiators and dashboards. And we've got awesome at visualizing process to some extent. And the irony here is we can't visualize the stuff we're building. Does that seem weird? Why is this important? Because if you want to move fast in the same direction as a team with technical leadership and vision, you need good communication. And that's essentially all this is about. There are two things we want to solve here. Number one is notation. And that's really easy to solve. Number two, content. Bit trickier, but we can still do that. I'm not going to go through all these boxes on this slide, but basically there are lots and lots of really simple tips for cleaning up notation on diagrams. You know, put a title on a picture. Make sure you have arrowheads on your lines, ideally pointing one way. Add a description or an annotation to every line so you understand its intent. You know, use color and shapes where appropriate, but make sure there's a key or legend to explain this stuff. We do often joke that naming is hard in software, and if this is true, and I think it is true to a degree, it makes absolutely zero sense that most architecture diagrams are just named boxes. That adds a bunch of ambiguity onto these diagrams. So what I do, and this is a really, really simple tip, all of my boxes have a name and some descriptive text. You know, either a short sentence or a list, some sort of bullet list of responsibilities. And that just gives you a really nice at-a-glance view of what that thing, whatever it is, what that thing does. Right, so notation's easy. Content. You can't show everything on a picture, on a single picture, because there's just too much detail. And if you go back to some of the older kind of classic architecture books, they'll all talk about views, viewpoints, perspectives. You know, there'll be a logical view of your system and a development view and a design view and an operational view and a deployment view and on all of these sorts of things. And basically, we're looking at the system, the architecture, the software, from a number of different perspectives depending on what our role on the team is. There are lots of ways to do this. This is a quote from Philip Critchton's 4+1 model. And he says, to describe a software architecture, we use a model composed of multiple views or perspectives. This is Philip Critchton's model. There's a logical view, which is basically your functional building blocks. There's a development view, which shows you how those logical building blocks, those functional building blocks, are mapped onto code. There's a process view that talks about concurrency, for example. And there's a physical view that talks about infrastructure and deployment. And you kind of take a scenario out of the pot, and you use these four different views to document that single scenario. A friend of mine, Owen Woods, Nick Rosansky, both based in London, in their book, Software Systems Architecture, they have a different model. It's called Viewpoints and Perspectives. And what it does is it builds upon the 4+1 model to rename some things and add some additional content. So they add a context viewpoint, which describes how your system fits into the rest of the world. There's a functional viewpoint, which is the same as the 4+1 logical view. This is going to get complex, so keep up. There's an information viewpoint, which is new. That talks about data. There's a concurrency viewpoint, which is similar to the 4+1 process view. There's a development viewpoint, which is the same as the 4+1 development view. There's a deployment viewpoint, which is like the physical view in 4+1, and they added an operational thing. You keeping up? The problem is, every book does the same thing. Every book takes this approach and renames some of the different views. And it just causes a whole load of confusion because most teams don't know which names to pick. You know, a design view to me might mean something different to all of you. And, you know, who's using physical infrastructure anymore? Why do we have this physical thing kicking around still? It's like some virtual view or something. The other thing you'll notice about all of these different view catalogs is that there's a weird separation between how we think of a system from a logical perspective and how we think of a system from a development perspective. That's odd. Kind of represents the handover between an architect and a development team. As the architect, I'm going to have my nice logical view, and it's all clean and beautiful. And then there's this other development view, which is a bit horrible. And we hand over. And they're two things, and they're separate all the time. That kind of strikes me as a bit odd. What this leads to a lot of the times is what George Fairbanks in his book, Just Enough Software Architecture, calls the model code gap. Essentially, when we have an architecture discussion, we might use terms like module, component, service, layer, subsystem. Good architectural sounding terms. The code does not contain these terms. So if you're a Java developer, does Java have a component keyword? It didn't when I looked half an hour ago. Does C# have a component keyword? Nope. Does C# have a layer keyword? Nope. If we're doing a hexagonal architecture, ports, adapters, is there an adapter keyword? Nope. So what we do is we create these architectural constructs using classes, namespaces, packages, interfaces, maybe folders. And sometimes the mapping doesn't quite work. We refer to a nice coarse-grained component in our architecture model, and when we open up the code, it's like, well, I can't see it, I can't find it. So there's no mapping. And this comes back to the question we asked right at the start. Does the diagrams reflect the code? Normally not really. And if the diagrams don't reflect the code, they're basically useless. There's no point in having them. They just look pretty on a wall and someone's going to get a pay rise. Woo. This talk is ironically not about drawing pictures. This talk is ironically not about visualizing software architecture. This talk is really about a shared vocabulary. And as an industry, we don't have one. We don't have a shared vocabulary to describe our software. And that seems a weird thing to say in 2016. I definitely grant you that. Quick quiz for you. Right, what's this? C'est Paris. It's a map of Paris. What's the big blue thing running through the middle? Right, it's the River Seine. What is a river? Come on, somebody must know what a river is. Stream of water, right, flowing in one direction or the other. We know what a river is. We can go and find other rivers. We can identify rivers. Right, going to start to get a bit more complex. What's this? It's a floor plan for a bathroom. What's this thing here I'm highlighting with my green laser pointer? It's a toilet. Yay, this is easy, isn't it? What's a toilet? Okay, you sit down. Right, we know what a toilet is. We can go and identify and find other toilets. Electrical engineering, circuit diagrams, whether they're schematic or pictorial. You know, there's a common way to describe electrical engineering things like resistors and switches and bulbs, whatever. If I had a big box of resistors and switches and other components in a box here, and I said, right, I want somebody to come to the front and find me a resistor. You can find me a resistor because you know what a resistor is. We can find it, we can identify it, we can see it, we can touch it. Now it's going to get super hard. We're ramping up the complexity massively. What on earth are these? So these are two components diagrams in UML, different versions of UML but showing the same things. Each of the boxes is a component. This diagram, well, these diagrams are kind of weird. So on the top one, you can see that we have UI components. On the bottom one, they're called application components, but they look like the same thing. On the bottom right corner, there's a database component. And the stuff in the middle is like a, facilities, student, seminar, schedule component. What are they? I get the database is a database, right? And that's a thing we can boot up and install and run. Are the UIs and the applications also separately deployable? And what about the stuff in the middle? Are they microservices, or are they components of the UI? Or are they components in the database? This diagram's not telling me a whole bunch of really interesting information. To make this really, really simple, and to illustrate my point, imagine we're building a boring web app in a database, and we're going to call this our system. When I have conversations about architecture with some people, for them, the web application is a component of the entire system. So I'm using the word component here. For other people on the same team, and this has happened a lot, that's a component. It's something running inside the web application. Do you see the problem? We're using the same word for very different levels of abstraction. And this tends to cause lots of confusion. So I'm going to throw at you the ubiquitous language slide here. You know, this is a craftsmanship conference. We've had a few talks about DDD and ubiquitous language, and I think that's awesome. It's a great way to make sure that we all have a common understanding of the business and the domain we work in. The irony of the ubiquitous language is we don't have one to describe software. It doesn't exist. Everybody has their own subtle variation on this. And as an industry, that's just bonkers. Imagine if the building industry did not have a ubiquitous way to describe site plans. You get all sorts of crazy houses popping up. So I think, forget the notation side, and this is why I said this talk is not about visualization so much, it's about abstractions. And I think having that common set of abstractions is way more useful than trying to force a notation like UML onto everybody. I think we'll get there eventually. I think we'll get to a point where we have a common set of abstractions and then we can layer some notation on top, like electrical engineering. But we're not there yet. If this sounds kind of foolish, let's go get two tourist maps of Paris and lay them out side by side. Two maps of Paris will show exactly the same things, the same abstractions. Arrondissements, the river, the sites, points of interest, the metro stations. But they might use different shading, colors, icons, and so on. Same abstractions, differing notations. A map is a really nice example of a self-describing document because there's a key in the corner, a legend to explain the notation. And that's a really nice, simple concept that we can borrow. So, how do I do this? I can't change the entire world, but I can tell you how I do this. So for me, a software system is made up of a bunch of containers. It's sort of unfortunate Docker came around, because I think I got there first, but whatever. And basically, a container is something that you need to deploy. It's something that's executable. It's something that runs. It runs your code or it hosts your data. In real terms, it's something like a web app, a database, a mobile app, a file system, a Windows service, a standalone application, so on and so forth. If we zoom into those containers, for me, they're just made up of components. So I want to consciously use the word component to mean something running inside a process, essentially. It's just a bunch of related functionality with a nice clean interface on top. And because I deal mostly with Java and C#, if you look inside my components, they're just made up of classes. That's it. This works really well for OO languages. If you are using JavaScript, then maybe it's not components and classes, maybe it's modules and object, or modules and functions. Haskell, F#, modules and functions. Database technologies, components, and stored procedures, right? You might have to take this type of approach, this hierarchical approach, and twist it for your technology stack. What I'm really trying to do here is I'm trying to create a single static model of my software system, and that's my core artifact here. And it's from the system level right down to essentially the code. And once you understand the static structure of your system, you can weave other stuff around it really, really simply. For example, if you want to show how a certain user story or use case is implemented and works, you can draw a sequence or collaboration diagram showing how things in your static model interact at runtime. Whether it's at the class level or the components level, that's absolutely fine. If you have a map of your infrastructure, your physical servers, for example, you can show your containers and how they're mapped onto the infrastructure. That's the deployment view. Clustering, sharding, availability, and so on. To bring this slightly back to pictures again, once you have a simple way of thinking about your system, you can draw some pictures really, really simply. And this is what I often refer to as my C4 model. And it starts with a context diagram, shows your system with stuff around it. You then zoom in, you see the containers inside the system. You zoom into certain containers, you see the components. What's this number at the top? 4. I normally stop at 3 levels, especially when I'm doing an upfront design exercise, because there's no need to go down to that nitty-gritty class level detail. If you want to, of course, you can go down to classes or code. But I normally stop 1 level up. Quick, simple example for you. When I moved back to Jersey in the Channel Islands, I wanted to find other tech people. So I built this site here called techtribes.je. It's a super basic content aggregator. Lists local people, businesses, blogs, tweets, events, jobs, whatever. That's a context diagram for the tech tribe system. The box with the monkey in the middle is my system. That's the boundary in my scope. We have different types of users, actors, roles, personas, however you want to model people. And there are a bunch of systems at the bottom that tech tribes interact with. So that's tech tribes and how it fits into the rest of the known universe. Sounds a bit grand, but that's essentially what it is. If this was interactive, we could select tech tribes, pinch to zoom in, and we get to the container diagram. So this is like the next level down. Still has people, actors, roles, personas at the top, and systems at the bottom. And this is literally just a zoom in of the tech tribe system. There's a web app at the top. That's the point of access for all of the users. There's a content updater at the bottom, a standalone Java process. It reaches out to Twitter, GitHub blogs, pulls the data back. And the data is either stored in a MySQL database, a Mongo data store, or the file system. This diagram tells you absolutely nothing about clustering, sharding, availability, deployment. That's a separate diagram. So this is just the logical high-level building blocks. Again, if this was interactive, we could take the content updater, pinch to zoom in, we get to see the components live inside it. And it's the same deal. It's just going down the hierarchy every time. Content updater is the kind of big gray box with the boundary. A bunch of components living inside it. External systems, containers at the top. We choose that tweet component, we pinch to zoom in, we see how that's made up. Right, so it's a very, very simple hierarchical model. You know when I did my introduction and I said, can you see Jersey on this little tiny map? And you went, no, because it's too small. I wasn't doing that just to be funny, although it is quite funny. I was doing it to plant the whole seed about maps. The diagrams I'm trying to create here are basically maps, zoomable maps of our software. And these zoomable maps help us navigate a large, complex software system. And of course, the different types of diagrams are different for different audiences. Now, as a developer, I like the zoomed-in view of the world. If I'm talking to a business person or a product owner, then I'll go higher with the context picture. If I'm dealing with operations and support staff, the container diagram works really well. Here's a bunch of web apps and databases. Make sure they don't fall over. Don't worry about what's inside them. Different levels for different audiences. I'm not saying you should only draw these types of diagrams. Again, this is just the static structure, and there are a whole bunch of other types of pictures you might want to draw to describe different things about your software system. This is not also a design process. I'm not saying you should do a context diagram, then a container diagram, and blah, blah, blah. This is just a collection of diagrams, a collection of structured diagrams that you can use to describe a system, both during upfront design and also retrospectively with existing code bases. Now, having said that, I had a tweet last week, and somebody said we basically tried C4 stuff and we liked it. And this is more interesting. The best part was implementing the software TDD style along the component diagram boundaries. So this is kind of doing just enough upfront design, understanding what the major components are in the system, where the responsibilities lie, and then doing TDD around them. I think that's a really, really simple, powerful approach. It's, for me, that's what just enough upfront design is all about. Tooling. One of the comments I get about this sort of approach is, well, that sounds great, and we can go through lots of whiteboards and lots of pieces of paper, but the diagrams will ultimately become out of date. That's true. If I do an upfront design exercise and I sketch out some nice pretty pictures, 5 minutes after I start writing code and starting to get some feedback, oh, my diagrams are wrong. Oops, I did it on paper. I can't erase it. I can't be bothered. Diagrams are now totally useless. That's a tooling problem. It's a tooling problem. We need better tooling to support the way we work. So let's fix that problem too. Right? It's a separate problem, but we can still fix it. The diagrams I showed you, they're just Visio, basically. OmniGraffle for the Mac, Visio, Glyphy, Draw.io, Create.ly. There are like a million tools out there. Apparently, these tools are state of the art for drawing software pictures in 2016. You can create templates if you want to smooth the process, drag a little person onto your canvas. These are still just general purpose, generic diagramming tools. You draw a box, you make the box the right size, you put some text in, you center the text, you draw the arrows, you line them up, blah, blah, blah. Building architects do not do this. I know there are some Visio templates for simple floor plans, but if you're building a skyscraper, you do not use Visio. I hope you don't use Visio anyway. Building architects use things like AutoCAD. AutoCAD is a sophisticated modeling tool where architects and engineers can build complex three-dimensional models of their buildings, and then they can surface different views, different diagrams, floor plans, site plans, cross-sections, elevations, detailed drawings. There's a fairly standard way to do this. The building industry is more advanced than we are because we can't do this. The irony is we build these tools for them. What? This makes no sense either. So yeah, the sketches get out of date. So why don't we just auto-generate the diagrams? Who's done this? Who's auto-generated pictures from a code base? Yeah, we've all given it a shot. What happened? A total mess. Does that mean your system was a mess? Maybe. But often it's just because those tools are showing you too much detail. Things like CodeCity, Structure 101, Lattice, Endepend, Sonar Explorer. There are lots and lots of static analysis tools, dependency analysis tools, UML round trip and reverse engineering tools. There are plugins for IDEs. The fundamental problem is those things see code. And I can show you a really simple example. For those of you who are not Java developers, there's a framework in the Java world called Spring. Spring does everything. There's a little sample application that shows how to build Spring MVC, web model view controller applications. You download it. It's a traditional layered architecture, bunch of controllers, bunch of services, bunch of repositories. You open the code in your IDE. You get a bunch of domainy sort of objects, classes, repository stuff, some services, some utils, because why not, and some controllers. You throw that into your automatically generating diagramming tool thing, and you get that. I have been criticized when I was showing this picture before to say, Simon, you could have at least made the boxes line up and made the arrows and the lines not overlap. It's impossible. It's too hard. This is only a really small toy system, by the way, like 20 or 30 things. Imagine if this was your big enterprise system with 100,000 Java classes. Right, that's why this approach is just useless. It does not scale. So yeah, the diagramming tools, the reverse engineering tools, they see code. They don't see components. They don't see those architectural constructs that we have in our architecture discussions. And really, that's what I'm more interested in seeing here. This is not a new problem. This is a paper from 1995, I think. Bridging the gap between between source and high-level models. In the first 2 paragraphs, it basically says, if you go to a team and you ask the kind of engineer to draw you a diagram of the system, they'll draw you a really nice high-level picture. probably modules, components, layers, whatever. If you reverse engineer a picture automatically from the code base, you'll get a really, really low-level accurate picture, but the automatically generated picture will not match the mental model that the engineer has. They're two totally different worlds. It's the model code gap again. And a lot of this comes down to, well, if we don't want to show classes, we want to show components. What's a component? And if I was to, distribute a code base here right now and said, right, identify a list of all of the components you can see in this code base, we'll all come up with different lists. So my approach here is, well, let's figure out the rules that we can use to identify architecturally significant elements. And what I mean by this is things like components. And if we go back to the Spring Pet Clinic example, I'm going to say, and you can shoot me after a beer later, I'm going to say that my model classes are not architecturally significant. Backs away from the DDD crowd. I'm going to say that the repository things are important because that was the bottom layer on the diagram. The service is really important, and you'll see why in a second. I really hope the utils are not important. That'd be very, very bad. And I think the web controllers are somehow important. So if we take this more kind of thoughtful, balanced approach and regenerated our automatically engineered diagram, you get something like this once you shift the boxes around. And this looks like the layered architecture diagram we saw before. Controllers, service, repositories. This diagram is still showing code. This diagram is still showing interfaces and classes and the relationships between these elements. So again, this approach will not scale if you have hundreds and hundreds of them. If this was a map, if this picture was somehow interactive and we could pinch to zoom out one notch, we could do something like this. We could say, right, I'm going to stick a stake in the sand and say each of my controllers is a separate thing, separate component. I'm going to say that the clinic service is a separate thing and each of my repositories is a separate thing. Of course, this is a toy example in the real world, so your repositories might have a bunch of helper classes and so on and so forth. But it's about that zooming out movement. And if we adopt that zooming out movement, we can draw a diagram that looks like this. So this is the same diagram, drawn with a different notation. And because we've zoomed out slightly from the code level elements now, you can much more clearly see the relationships between these components. So that's what I'm shooting for here. That's what I'm aiming for. The code is the single point of truth. The code embodies, the architectural ideas and the final realization of essentially the requirements, the user stories. Can we get that back from the code, though? Given any code base that you give me, can I reverse engineer automatically an architecture diagram based upon stuff I only find in your code? Well, we can try this out. If I want to draw something like a context picture, here's your system and stuff around it, can I get a list of your users, your people, your roles from looking at the code base? And the answer is, well, maybe. If you're building a web app, maybe you have a configuration file that maps role types to URLs. Maybe there's an enumeration in your code that lists your user types. Maybe there's a database table. We're going to have to work hard to get that, but it's possible. Can I get a list of systems that you depend on from scraping information purely from your code? A bit tricky. I could look for configuration files with API endpoint definitions in. I could look for things like libraries on my class path of my Java app. If I see Twitter4j.jar, I can make an assumption that my system talks to Twitter, but I don't know why. There's no intent. What about those nasty situations where you dump a file on a file share and someone else picks it up? I know that sounds archaic, but it still happens. You drop a message on a message queue and it disappears to 20 other systems. Again, there's a lot of implicit information there that's lost. Zoom down. Can I draw a container style diagram automatically by looking through your code? Maybe. If you have a Visual Studio solution with all of your code in, we could look for the various types of projects, identify the web apps and the console apps and the services. We could scrape project metadata. We could look for build artifacts in your Maven build. We could look for Docker images and uses of Vagrant, and we could look for deployable things we're trying to create here. But it's going to take a lot of work. Zoom down again. Can I get a list of components from your code base? The answer is potentially yes, with a huge caveat. And the caveat here is, can you identify the components in your own code base? So what's the set of rules that you will use to identify your components in your own code base? And this is really coming back to George Fairbanks again and his model code gap. He says one simple way to bridge the model code gap where the things, the abstractions don't match, is to adopt an architecturally evident coding style. In other words, make your code reflect your architectural ideas. There are lots and lots of ways to do this. In simple terms, it's things like adopting a naming convention. Adds the suffix component or service or controller or repository in a consistent fashion. It could be using things like annotations or attributes, machine-readable metadata. Could be packaging conventions. There are lots of ways to adopt an architecturally evident coding style. Once you understand these sorts of rules, you can then find your components in your code base. Maven modules, OSGI modules, Java 9 modules in the future. JavaScript is a bit tricky, but Actually, microservices is another really good example. If anybody here is doing a microservices style architecture, and I ask you to draw me a picture, you'll probably draw me a picture of a bunch of services collaborating. I'm pretty confident I can find each of those services in the code fairly easily. Right, so there's a nice one-to-one mapping between the concepts. What I really want to do here is extract as much useful information as I possibly can from the code automatically. And the stuff that's harder to get, I'm just going to supplement that on top of the model. I want to mainstreamify, I think I just made a word up, I want to mainstreamify architecture description languages. An architecture description language, these things are well known in the academic arena, in the research arena, but they're not basically known in mainstream software development. Instead of drawing a picture to describe your software system, you write some text. And that text typically describes the static structure of your system. There are a few examples out there, but they're not widely used. But it's a great concept because we're developers and we like text. And we can diff text and we can version control text and we can check it in and all this good stuff. So let's just do that using code. Right? Let's create an architecture description language, essentially a domain-specific language for describing static structure with code. And that's what I've done. So there are two open source libraries, Structurizer for Java, Structurizer for .NET, and basically they are small libraries that implement the C4 model. Essentially there are a bunch of classes in there for people, software systems, containers, components. And all you do is you create these things and wire them together. It's all open source, all on GitHub. Right, vendor alert. So with my vendor alert hat on, I created a startup end of last year called Structurizer, and it's a set of web-based tooling to draw pictures based upon these models. Essentially what you do is you write a little program that describes your software system, hopefully by extracting information out using static analysis and reflection techniques. You throw that up as a JSON document via a web API, you draw some pictures. If you really hate using Visio and you want to draw an architecture diagram, this is as simple as it gets. You create a model, you add a person, you add a software system, you say that the person uses the system, you create a view, you add some styling, you throw it up to the API, you're done. It draws a picture. You add more code, you get more pictures. That's not where the power of this technique lies. Let's go back to my Spring Pet Clinic example. Let's say I want to model this system with code. Well, all the Spring Pet Clinic system is a user, an employee of the pet clinic, the vet, the animal hospital, using the system. So we can just write some code to say that. Create a person object, create a software system object, wire them together, done. We zoom down to containers. Essentially, this is just a web app talking to a database, right? So let's just describe that in code. create a container object for the web app, one for the database, say that the user uses the web app and the web app uses the database. And we're done. I don't want to have to use this approach when I get down to the level of components because that's going to change quite rapidly. And that's where the open source libraries have this concept of a component finder. And basically, it's a bunch of additional code that works using static analysis and reflection techniques with a set of pluggable strategies to find components in your code base. So, for example, finding classes that end in the word controller, finding classes with a particular annotation, that sort of thing. So these 5 lines of code basically find components in the Spring Pet Clinic code base. In this case, all we're doing is we're finding the @controller annotated classes, the @service annotated classes, and the @repository annotated classes. And we're finding all their dependencies as well through static analysis. Done. Because this is code, we can add some more dynamic stuff. So we can say, go find me all of the controllers that you just found and make the user use them. And go and find me all of the repositories you just found and make them use a database. We create some views in memory, one for the context picture, one for the container picture, and we create a component view for the web app. We add some styling, we throw it up to the API, we get some pictures. So that's the context diagram for the Spring Pet Clinic system. It's the user using the web app. That's the container diagram. It's the user using the web app using the database, and that's the diagram I showed you before. All completely automatically generated, apart from the layout of the boxes, I must add. You'll notice there's some commentary, some descriptions in the boxes. That's actually just come from the Java doc. So I'm trying to get as much useful information as I possibly can from the code, both the compiled version and the source code where possible. Because it's a model, see, I've got the word model in here now. We've created a model, and because it's a model, we can do things like automatically generate diagram keys. That's easy to do. Because it's a model, we can link the model elements with the source code. So in this case, if you go to the live diagrams and you double-click a component, you get to the page on GitHub for the interface in this case. Again, all easy to do because it's just a model. And they're basically maps. It's a set of maps. You double-click the system, you go into the containers. You double-click a container, you see the components. It's a set of zoomable maps on top of our software system. Does this approach scale? If you have a big system, you're going to have a lot of components. I don't recommend drawing a single diagram with all of those things on. So this is a component diagram for my Tech Tribes web app. I can explain it to you, but I shouldn't have to. It's just there's too much detail on here. But because this is a model and not a static picture, we can just write some more code to slice the model how we want to. In this case, rather than show all of the components for the web app, I'm going to create one component view per slice of the system, per slice of the app. In this case, per controller. So go find me all of the controllers, create one slice per controller. The net result is essentially a bunch of simple pictures. Once you have a model, of course, you don't have to use my tooling, because all of the client libraries are open source. You can throw it through D3, JavaScript in this case. You get a nice visualization of the tree structure. You can throw it into GraphViz. There's actually a dot file exporter. I'm using Cyril Martre's dot file exporter thing, and I've plugged it into Structurizer. Or you can get really fancy and throw it into Neo4j. Why not? It's just a graph. And then you can do things like query your software architecture model. If you hook all of this into your build pipeline, guess what happens? You get diagrams to stay up to date. And this is great for a fast-moving, volatile code base. A couple of quick notes on this before we go for beer. There was an article based upon a virtual panel from 2009 on the state of software architecture documentation. A bunch of famous people involved. They all said similar things back in 2009. I want to see the architecture in the code. I want to embed architecture information in the code. The documentation should be free. I want somebody coming to me who's never worked with me before and they understand what I'm talking about. We've not got there yet. And I hope some of what I've spoken about this evening is a way to get us some of that way. Because it's 2016 and we should stop using Microsoft Visio for drawing pictures. It's just nuts. So this whole thing is very much still an art. There are no right ways, no wrong ways to visualize software architecture, to describe software architecture. But the one thing I would urge you to do, and this is my closing comment, make sure that within your team boundaries, you have a ubiquitous language to describe your software. I will be around upstairs with beer. Thank you very much. And if you have any questions, feel free to grab me afterwards. Enjoy your evening.